Lesson 11.8 is rational equations and functions. So what we're going to do in this section is we're going to be solving. We actually have an equation, so we have an equal sign in it. They want us to solve for x. If you remember, what we've done in lesson 11.4 to 11.6 is we simplified fractions, we multiplied and divided them, and we added and subtracted them. And then in lesson 11.7 yesterday, what we went over, we learned how to divide polynomials. Now, when you divided the polynomial, then you had to technically simplify a fraction. So you used what you learned in 11.4. But when we went over 11.6 and we had to add and subtract fractions, what did I know I had to have in order to add or subtract fractions? Common denominator. Yes, correct. So I have to have a common denominator in order to add or subtract fractions, which is what we're kind of going to be working on again today. What I know in example 1 here is that they've already given me the entire problem. I know that 2 over x plus 1/3 equals 4 over x. I have the entire equation. Anytime there's an equal sign, they usually want your end result to be x is equal to whatever it's equal to. All right? So our mission is going to be finding out what number represents x. Okay? Or x represents what number. In order to do that, before I can do anything, what do I know fractions have to have in order to be added or subtracted? Common denominators. So before I can do anything, I've got to get a common denominator. So let's look at all 3 of these denominators. What would be a good common denominator? 3x. Perfect. So then I just go through and I ask myself, okay, if my common denominator needs to be 3x and there's already an x there, what am I going to multiply by? 3. Whatever I do to the bottom, I've got to do to the top. Now, if my denominator is already 3, and I want it to be 3x, what do I multiply by? X. Whatever I do to the bottom, I've got to do to the top. And last but not least, if my denominator is already x, and I want it to be 3x, what will I multiply by? 3. Whatever you do to the bottom, you got to do the top. Now, here's the shortcut. Are you ready? If we don't have to work with fractions, we're not going to. Because it'll be much simpler for you guys if we don't have to work with fractions. So anytime you are simplifying an equation, that means I've already got the full equation. We have something plus another thing equals whatever it's equal to. I can just sit here after I've already got my common denominator and just cancel out the denominators. I don't even want to work with denominators anymore, so I'm going to just work with my numerators. What's 3 times 2? Plus 1 times x is 1x is equal to 4 times 3, which is 12. Now I just have a regular equation that I can work with. I don't have to worry about simplifying a fraction. Okay? Now, let's just solve for x. What would I do first? Subtract 6. And 1x is equal to what? 6. Now, do I need to divide by 1 here and get what x equals? No, because anything divided by 1 is still it. So what does x equal? 6. Here's my final answer. Just like that. Okay? Now let's look at the next set of fractions here. We have x over x plus 9 equals 9 over x plus 9 plus 2. Well, in order to add or subtract fractions, I've actually got to have fractions. So, what do I need to do to one of these terms? Put it over 1. Very good. So, we're going to do 2 over 1. That way I can see all of my denominators clearly. I have x plus 9, and 1. What would a good common denominator be? X plus 9. So, do I need to do anything to these 2 fractions? Nope, they've already got the common denominator. But what do I have to do to the third fraction? Multiply by x plus 9. Multiply whatever I do to the bottom, I got to do to the top. Now that I have common denominators, what can I do to those denominators? Cross them out. We don't even need to worry about them anymore. And I have x is equal to 9. plus, now watch this. Is everybody watching? This 2 has to be distributed to both the x and the 9. So I'm going to have plus 2x plus 18. Don't forget that step. People usually go 2x plus 9. No, that 2's got to be distributed to everything. So that means I've got to have 2x plus 18. All right, so now what we want to do is we just want to add like terms so that I could solve for x. Somebody tell me, what are the like terms that are already together on one side? 9 and 18. So do I need to subtract 9 to combine with 18? No, we just add them just like they are. So what's 9 plus 18? 27. X equals 2x plus 27. Now what would I do? Subtract 2x. Perfect. It needs to go over here to combine with its like term. What's that number in front of x? 1. So 1 minus 2x is negative 1x is equal to 27. Now, can we do this like our other one and just say, oh, x equals 27? No, because anytime you have a negative, we actually have to divide by a negative because it's going to change the sign. And what does x equal? Negative 27. All right, that's how we solve for x whenever we want to get the least common denominator, or we could just call it a common denominator, okay? All right, the last example that we're going to do is the exact same type of thing. We got to get a common denominator so I can solve for x. So I have x, 8, and 4. What would be a good common denominator? 8x. Very good. I can't say 4 because I never, ever, ever want to divide to get a common denominator. So I say 8x. So what do I need to multiply by the first fraction? 8. What do I need to multiply by the second fraction? And the third? 2x. Very good, because we've actually got to make the 4 and 8, so we have to multiply by 2, plus give it an x, so we do 2x. What can I do to my denominators now? Cross them out. And what is going to be my equation now? Equals 6x. So we've got 16 minus x squared equals 6x. Do you see any like terms that we can combine here? No. So I cannot just easily solve for x because I've got an x squared and an x. So guess what we're going to have to do? Factor. Now, let me give you this little helpful hint here. Is everybody paying attention? Because you need to listen to this. You never, ever, ever want to deal with a negative number in front of x squared. Ever. It's going to mess up your signs. It's going to make it really hard to factor. You just don't want to do it. So instead of saying, okay, let's just subtract 6x and move it over here, I don't want to do that because I'm still going to have a negative x squared. What can I do instead?
Add x squared.
Perfect. Add x squared. It will cancel out over here, and I add it over here. So now I have 16 is equal to x squared plus 6x. What else do I need to do now? Subtract 16, because remember, whenever we factor something, I've got to get one side equal to 0. So I have 0 is equal to x squared plus 6x minus 16. Now I can factor and solve. What am I going to do to factor?
No, what's the name? AC? No, not AC, but the other one.
List the factors of 16. Perfect. We don't have to do AC because there's no number in front of x squared. Now, guess what? If there would have been a number in front of x squared, or negative 1, we would have had to do AC factoring, and you don't want to do that. So we have 1 times 16, 2 times 8, and 4 times 4. Which factors will I choose? 2 and 8, because they need to subtract to give me 6. So now I have x and 2, x and 8 equals 0. Now, does it matter that I've switched the 0 from the front to the back? No, not at all. We can put it on either side we want. I just like to put it at the back because it's easier to read, I think. What do my signs need to be?
Negative positive.
Negative 2, positive 8. Very good, because when they add together, they need to give me positive 6. Now, on a lot of the tests that I graded from the last one, people did this. Box that in. I'm done. That's my answer. No. Whenever you're solving for x, your final answer should say x is equal to a number. And we should get that. Well, in this case, we're going to have 2 answers for x. So how would I solve to get x?
X subtract 2 equals 0.
Perfect. And?
X plus 8 equals 0.
Very good. I just break it into 2 problems because each of these sets of terms equals 0. What would I do to solve for x in the first one now? Add 2. X is equal to 2. Then subtract 8. And x is equal to negative 8. Anytime you have to factor, you should have 2 answers. All right? Okay, this is going to be your classwork assignment. I'm actually going to do number 22 with you because it's not like one of the examples that we did. Then I'm going to give you some time to do 26 through 30, and then we will go through and we will answer the questions together, or we'll work them out together. So go ahead and get out your books, open it up to page 694, and we're going to start with number 22. All right, on number 22, okay, we have to get a common denominator. But look at our denominators. What do you see that you can do to one of these denominators to simplify it? What is that? 3x minus 12. What could I do to 3x minus 12 to simplify it?
3.
Exactly. Take out my GCF of 3. Now, so if I pull my 3 on the outside, what am I going to have left in parentheses?
1x.
X or 1x minus 4. Now watch this. This is going to make it so much easier for me to find a common denominator now. Because I've got 3x minus 4, x minus 4, and 3. So what would a good common denominator be? 3 times x minus 4. So do I need to do anything to this denominator right here? Nope, it's good just like it is. What do I need to do to the second denominator? Multiply by 3. Whatever I do to the bottom, I got to do the top. And what do I need to do to the third denominator? Multiply by x minus 4. Whatever I do to the bottom, I've got to do to the top. Now that I have my common denominators, I can just simply cross through them, and we solve. So now I have 7 minus 3 is equal to what? 2x minus 8. Perfect, because I've got to distribute that 2 to both terms. Now, we just can combine like terms and solve for x. What would I do first? 7 minus 3 is? What would I do now? Add 8. Perfect. Why wouldn't I subtract 4? Because then there would be nothing left on the one side, and I've got to have something on each side. So now I've got 12 equals 2x. What do I do now? Divide by 2. And what is x equal to? Whoops. Very good. Okay? That's exactly how we do number 22. Now I want you to take a few minutes. I want you to do number 26 through 30, and then we will come back and work them together. All right, let's go over the answers to number 26. We've got 1 over 4 plus 4 over x equals 1 over x. What would a good common denominator be? 4x. So what do I need to multiply by the first fraction? X. What do I need to multiply by the second? 4. What do I need to multiply by the third? 4. All right. Cancel out our denominators, and I have 1x plus 16 is equal to 4. What would I do now? Subtract 16, and I get x is equal to negative 12. That should have been your answer for number 26. Number 28, we have 1 over 5 minus 2 over 5x equals 1 over x. What is a good common denominator? 5x. So what do I need to multiply by the first one? X. What about the second one? Nothing. It's fine just like it is. And what about the third? 5. So I can cross out my denominators, and I have 1x minus 2 is equal to 5. What would I do now? Add 2. And what is x equal to? 7. Perfect. All right, now number 30. This is the one that you might have had a little bit of trouble on. Number 30, we have x plus 42 over x is equal to x. Now, what would I have to do before I do anything? Put x over 1. Now, what's a good common denominator? X. So do I need to do anything to my first fraction? No, but what do I need to do to my second? Multiply by x. Cancel out my denominators, and I have x plus 42 is equal to what? Do I have like terms that can be added together? No. So what do I need to do? Factor. But before I can factor, I've got to get everything to one side and the other side to equal 0. What am I going to move? If I move x squared, what am I going to be left with in front of x squared? A negative. Do you ever want to be left with a negative number in front of x squared? No. So let's not move x squared. What should we move? Everything else. We could subtract x, and then we could also subtract 42. We can do it all at one time. X squared minus x minus 42 equals 0. Now I can factor. The factors of 42 are 1 times 42, 2 times 21, 3 times 14, and 6 times 7. Which ones subtract to give me 1? 6 and 7. So I'm going to have x and 6, x and 7 equals 0. And what are my signs going to be? Positive 6 and negative 7, because they've got to add to give me negative 1. Now, is this my final answer? Nope. I'm going to do x plus 6 is equal to 0, and x minus 7 is equal to 0. Subtract 6 on both sides. X is equal to negative 6. Add 7 to both sides, and x is equal to 7. Those are my final answers. Okay?